first. So first we're going to give the license identifier, and we're going to take this pragma, and we're going to use this 8.0 version, the latest one, and we're going to call our contract staking DApp. And the one suggestion I want to give you all, that first write the entire smart contract as it is without making any changes. Give the exact variable name, and once you complete the entire project, after that you can do the experiment and change the functionality, change the variable name as per your requirement. So we have called our contract staking DApp. Let's take this ownable, and we're going to take this re-entrancy guard, and we have the library which we had talked about in the last video, and these library we're going to use it. So I'm just working on the staking contract, but later we're going to import the library, and we already have this function like ownable and re-entrancy guard. So let's come here, let's define our safe math library, because we have to do the transfer of the token, so we need that library. So let's call this IERC20. So we got the library. Now what I'm going to do is I'm going to first build the entire skeleton of the smart contract without building the actual logic in the functions. So let's build the skeleton. After that we're going to take one function at a time. So we're going to take the struct, because altogether we're going to have 3 structs. So let's define our first struct, and it's going to be for the users. In that we're going to keep certain information about the user, that how many tokens they have taken. Okay, so that's the first struct, and the second struct is going to be for the pool. So let's call this struct pool info, and the third struct is going to be for notification. So let's call struct notification. So this is the 3 structs we are using. Now we can come back here and let's define a couple of state variables. So let's come here, let's define our first UNT variable. It's going to be decimal, and we want to have a way 80 decimal points. So we'll take this 10 and we're going to multiply with 18. And the reason why I'm taking this variable, because we're going to do the transfer of the token, and when the user will claim the reward is going to be in the decimal and way, so we have to take that into consideration. So that's why I'm taking this variable. We got our decimal. Now we can come back here, and we're going to take one more variable for the count. So we have to count the total number of pools which admin will create. So it's going to be a public, we'll say pool count, and by default we'll go with this normal without any declaring any variable, because this is going to be dynamic. When we'll create the pool, it's going to be increment. So we got our pool count. Now we can come back here and let's define our pool array. So we'll say pool info array, and it will be public pool info with small p. So we got this. Now we can come back here, and now we have to define the mapping. So we can come back here, let's take this mapping. In that we have to pass the address of the user, and it's going to return the UNT variable, means the balance of the user. So we'll say public deposited token. We got the first mapping. Now we have to get the second mapping. So we'll click mapping, we'll take this UNT 256, and it's going to map with the address, and it's going to return the entire user information. So we'll say public user info. So this is the 2 mapping we are using, one for token deposit and the other one is for the user information. So we got that. Now we can come back here, let's take this notification array, and we'll say notifications with S. So these are the variables we are using, and we need this part. Okay, so we are using this ownable, re-entrancy guard, save math library. We have our struct for user info, pool, notification. This is the state variable we have. We're done with that. Now let's build the skeleton for the function. So let's call this contract function. The first function we have to build is for the add pool. So let's call this add pool, and let's build the skeleton first. So this is the one function we have to create. The second function we have to create is deposit. The third function we have to create is, let's call this withdraw, and the fourth function we have to call is it's calculate pending reward. So this particular function will give us that what reward user have in the contract. That's the fourth one. Let's write the fifth one. It's going to be, let's call pending reward. Let's remove this one and bring it back. We got the pending reward. Now the next function we have to write for swap. So this function will call by owner of the contract to withdraw the token out of the staking contract. So we'll call it swap. Then we have to build another function for modifying the pool. So we'll call it modify pool. Then we can come back here. Let's define another function called claim reward. Then we'll have another function for creating a notification. So we'll say create notification. And the last function is going to be get all the notifications. So we'll say get notification. So this is the entire functionality of our smart contract for staking DApp. So we are using this particular version. Once we complete the smart contract, then we're going to import our library. So this is license identifier. This is the library, ownable, reentrancy guard. This is the math library. Here we have the struct. Then we have our state variables, mapping, and this is all the function we have in our staking contract. Now what we can do is let's start writing with the struct. So this is what we have. Let's start writing with the user information struct. So in that we're going to keep couple of information about the user. So first thing is going to be the amount, the number of token the user will deposit in the staking contract. That's the first thing. The second thing is going to be the reward, the last reward at. And the third thing is going to be the lock period, when he deposited the token. So it's going to be a uint variable. We'll say lock until. So only these three information we need about the user. That's what we have for the user information. Now we can start working on the pool info, and it's going to keep a lot of data. So first thing is going to take the deposit token. So we're going to take our interface, ERC20 interface. We'll say 20 deposit token. Then we have to take the reward token. So we'll use the interface and we'll call it reward token. Then we're going to take the total number of token the user will stake in this particular pools, means all the user will stake. So we have the deposited amount. After that we have to take the percentage, the APY, and the last one is going to be the time. So we'll say it's going to be a log day. We'll say log day. So these are the 5 information we are providing in our every single pool: deposit token, reward, deposit amount, APY, and log day. So things are look good. I hope you guys can understand the logic. So this is the user info, and here we have the pool info. Now we have to write the data for the notification. So in that, first we're going to take the uint variable, means the pool ID. The second one is going to be the amount. The third one is going to be for the address, the user, and the last one is going to be the message, means the type of, whether it's a claim, withdraw, or deposit, and only this information. And then we have the timestamp, means when we have called this particular function. So only this 5 information we are taking in the notification. So we are done with all the 3 struct. Now we have to move to the other part. So this looks good, this looks good, this looks good, and all are good. Now we're going to start working on our very first function called add pool. And in this particular function we have to add couple of data like staking token, reward token, and the lock period, and the APY. So let's provide that. So first is going to be the staking token. So we're going to use this ERC20 interface, and we'll say deposited token, and we'll have the reward token. We'll have the uint variable for the APY, and the last one is going to be for the day. So we'll take the uint and let's call this lock days. These are the information we're going to provide in our add pool function, and it's going to be a public, and this function can only call by the owner, and we are getting this only owner, and this particular function will come from the library we're going to import. Just build that function, and in that we're going to write the entire logic. So we're going to receive all of this data. Looks good. Now what we can do is we can simply come back here. Let's build the logic. So first we have to get the pool info. So this is the pool info. Here we have the pool info, and we have to push. So we'll take this pool info dot push, and we have to simply update all the information. So we have the pool info, we'll take as an object, and let's update the information. So first is going to be the deposited token. We'll say deposited token. You have to check your spelling, and it's coming from the function input. So we'll say deposited token, this one. Then we have to provide the reward token. We'll say reward token. Then we have to provide the deposited amount. So by default it will be 0. Then we have to provide the percentage, so it will come from the input, and then we have the log period. So this is the entire information we have for add pool. That's the only thing we have to do. So once we provide all of this data, we have to increase the pool count. So if you come back to the pool info, this is what we have. So make sure to double check your spelling. Let me do that very quickly. So everything is good. Now once you provide all of this data, we have to increment the pool count. So let's come back here, let's call this pool count, and we have to increment. So when we'll create the very first pool, it will become 1. When we'll create the second, it will become 2. And this information we need in the front end so we can run the loop to get the data from the contract. So that's what we have. Looks good. And that's the only thing we have to do here in the add pool function. Now we can start working on our second function. So in that we have to take the pool ID. The second one is going to be the amount. So this is the only two function we need, and it's going to be a public. So anybody can call, and we have to call this library because we have to prevent the re-entrancy attack. So we'll say none re-entrance. So we have our library. Now we can start building the logic. So first thing we have to do is we have to get that specific pool and the user information. So before we do that, we have to check for a condition that whether the amount is greater than 0. So let's do that. So we'll say amount should be greater than 0. If it's not, then we have to throw the error. So that's the first condition we have to check, greater than 0. Once we do with that check, now we have to simply find the specific pool and the user information. So let's get the pool. We'll say pool info, storage, and we have to simply get this pool info, and that we can provide the ID, and we'll get the information about the pool. Now we have to find the user. So we'll take this user info, storage, user, we'll say user info, and that we have to provide the pool ID and the user address, message.sender. In that way we can have the pool, specific pool which user wants to create and deposit their token, and we'll also have the user information. Once we have this, now we have to do a check. So if all user is already deposited the token previously and he tries to deposit more token, then in that period he might have earned any reward. So if he had earned any reward, we should transfer that reward to that user. So let's check for that condition. So we'll say if user.amount exists, if it's greater than 0, then we have to check for the reward. So let's call this UNT, and we'll say pending. It's going to be a reward, and here we have to call the internal function. So this is the function we have to call, like this one, calculate pending reward. So simply copy, and that's what we're going to simply call here, and it's going to give us that how many reward user have earned so far. In that we have to pass the entire user object and the ID, and we'll have the information about the reward. So once we have this information, means if the user have any token exists and if he earn any reward, then we have to simply transfer that. So let's transfer the token. So we'll take the pool reward token because that's what we are transferring. We'll call the transfer method we have, and in that we have to simply pass the message.sender and the amount pending, the reward amount. So user can receive the reward he earned if it deposited token previously. And here we can simply call our notification function. So we'll say create notification. In that we have to simply pass couple of information. So the first information we have to pass the ID, because if you look at here, ID, amount, user, type of, and timestamp. Then we have to pass the amount is going to be the pending. Then we have to say message.sender, type is going to be, let's say, claim. And these are the information we are passing. But if user don't have any token, then we have to continue ahead and build the logic and deposit the token. So we'll take this pool dot deposited token, and we're going to simply call this transfer from. In that we have to take the token from the user and transfer to the contract address. So first we're going to simply take the user address, then we'll take the contract address. So to get the contract address, we can call this particular method called address. This will have the address of the contract, and we can simply pass the amount. So this is the amount which user will provide. So in that way we can able to deposit the token in the contract. So once we have that, now we can come back here. We can take this pool deposited, and we have to simply increment and that. So in that way what we'll have, we can able to know that how many tokens have stake in a single pool. So once we have increment that, now we have to simply update the time in the user info. So we'll increment the number of the token, then we have to simply increment the last reward at, so we can get that block.timestamp, and we can simply come back here. And here what we can do is, here we can simply take the user and we can simply call this lock until and block.timestamp, and we're going to simply add the day, and we're going to simply multiply with 86400. So 86400 is actually 24 hour. In 1 minute we have 60 seconds. So if you're going to multiply, you're going to get this for 1 day. But for testing purpose, I'm going to simply comment this and I will go for 1 minute. In that way I can able to test and show you instantly. Otherwise I have to deposit token and have to wait for 1 day for making the transaction. But in actual real world, when you will launch your application, you should always allow user to stake the token for 1 day period. Okay. So what I will do, I'll simply replicate this. I'm going to comment this, and for the testing purpose, I'm going to decrease this to 60 seconds. Means if you pass one, it will become 1 minute. But on the other one, on this top one, the stop one for 1 day, and this one is for 1 minute. I hope you guys can understand this basic calculation. So this looks good. This is fine. Now we can continue ahead. We can come back here and we'll call this deposited token. We'll take this address. In that we can take this pool deposited token, and we can simply increment the amount. Now we can simply come back here and we can simply copy this, and we can simply display the notification that deposit, and we have to change this to amount, and the rest would be fine. So I hope you have understood the logic, that what exactly we have done. We are taking the ID and the amount, we are checking for the condition, then we are getting the information about the pool and the user. After that we are checking that if the user is already deposited the token, then he might have earned some commission. If he earned any commission, then we have to transfer that commission to the user wallet address, and that's what we are doing here. After that we have to simply continue and deposit the token in the contract, and that's what exactly we are doing, and updating all the state variable. You can see user, and here we are going with the 1 minute, but in actual world you can go with 1 day. Looks good. And here we have the notification. Let's format this. So that's our deposit function. Now we have to write the withdrawal function. In that we have to simply pass the same thing. So we'll copy this one and we can provide here. Then it's going to be a public. We'll have this no. Inside that we have to do the same thing. So we have to simply copy this portion because we need the information about the pools and the user. So once we have that, now we can simply get this check as well and paste here. And here we can change this to user amount. It has to be like greater or equal to amount. And we can change this message to, let's say, withdraw amount exceed the balance. Simple. Once we do with that check, now we can come back here. Let's do the second check. So we'll take this user lock until. So we have to check the period that the user has to wait till the lock period get completed. If it's not completed, then we are not allowing user to withdraw the token. So we'll check this. We'll say less or equal to the day lock. So we'll take this block.timestamp, and we can simply lock is active, means you cannot withdraw at this moment. You have to wait for the time to be complete. So once we're done with that check, now we can come back here, and here we have to take this UNT. We have to calculate the reward which user have earned. So we're going to use this internal function, and we're going to pass the user object and the ID. This will give us the reward. And here we're going to build a if statement. Simply copy this one, and that's what we can simply paste here. And here we're going to simply remove this, and we can see we are simply transferring, and the rest will be fine. You don't need to make any changes. Just this is going to be exactly the same. Now we can simply come back, and now we have to allow the user to withdraw. So let's build that logic. So we'll take this if amount is greater than 0, means if user have any fund in the contract, then we'll take this user amount. We have to simply subtract that from the actual user balance, and we're going to take this pool dot deposited amount, and we have to decrease that as well. Then we have to say deposited token. We're going to take the address, means the contract address, and we'll pass the pool deposited token, and we have to simply call this minus the actual amount. Once we're done with that, now we're going to simply come here. We'll take this pool deposited, and we have to simply transfer the token to the wallet user address. So we'll take the message.sender and the amount. So I hope you guys have understood that what we are doing, we are first changing the state of the user. After that, we are transferring the token. So once we're done with that, now we can come back here and we can take this user last reward, because that's the data we have to update, because user will also claim the reward. In that, we can simply take this block.timestamp, and then we can simply take this notification, copy and paste here. In that, we have to simply pass the pool ID, the amount, and the rest should be fine, and this is fine. And here we have to change this to withdraw. Looks good. And that's the complete function for withdrawing the token from the staking contract. So this looks good. I hope you guys can understand. It's a very simple logic. We are updating that, and then we are simply allowing user to withdraw the token and initializing the notification. Now we're going to start working on our call pending reward. So in that, we have to simply provide two things: the user information, user info, and the ID of the pool. It's going to be an internal function, view, and it's going to return returns. So what we can do, we can come back here. First thing we have to do is to get the pool. We can say storage pool. We'll take this pool info, and in that we can pass the ID, so we can get that particular pool. Once we have the pool, now we have to simply calculate the day passed. So we'll take this, very easy. We can take block.timestamp, so we'll have the current time. Then we're going to simply subtract with the last user reward at, and we're going to multiply with the time log which we are allowing user to stake. So it's going to be 1 day, and we have to pass that 1 day into seconds. So it's going to be 86,400. But I'm going to go with 1 minute. So I'm going to simply comment this one, and this will be 60 for 1 minute. I hope you have understood the logic we are applying. Once we're done with that, now we can come back here. Let's build a if statement. We'll say if day passed is greater than the pool.log days, then we have to simply say day pass, and we can simply say pool.log days, and we have to update that. And at the end, we have to simply return the entire calculation, the fund. So in that, we can simply say user.amount, and we have to simply multiply with the day passed, and we're going to simply deal with the 365 and 100, because we are dealing in the percentage, and we're going to simply multiply with the actual APY. So we'll have that data in the pool APY. This is a very simple calculation. I hope you guys are good in mathematics. You don't need to be master. You have to have a basic understanding that how percentage and simple multiplication work. And that's the only thing we have to do here. So what we are doing, we are getting the pool. Then we are checking for the time log, that how many days have passed. Then we are setting up that data. Then we are simply returning the actual amount the user have earned. And that's the entire function for calculating reward. Now we can come back here, call pending reward, and that's the one which we have to work. In that, we're going to receive a couple of things. So first thing is going to be the ID. The second one is going to be the address of the user, and it's going to be a public view return, and it's going to return the UNT, and it's going to be a very simple one, because the above function I have to simply call it. So we can come here, we can simply do one thing. We can simply copy this, and that's what I can paste here. Let's change this to user address, and we can simply call this return, and in that we can simply call the pass the function. So we have this call pending reward, and that we can pass the user object and the ID. We can pass the user object and the pool ID, and that's the only thing we have to do. This will return us the pending reward which user is going to get. So that's the function we have for pending reward. Looks good. Now we have to work on the sweep, and this particular function can only call by the admin of the contract. So in that, we're going to receive address of the token and the quantity of the token we want to receive. It's going to be an external only honor. First, we have to get the token available. So we'll take this token balance, and we have to check in our contract. So we'll take this interface, and in the part we can pass the token address. We'll call this balance of, and we'll say address, this means the contract. So in this way, we can able to find out that how many token is stake in the contract for this particular token. So once we have that, we can simply call this particular function called amount should be less or equal to the token balance, means the user wants to withdraw. Otherwise, we have to simply throw the error message. We'll say amount exceed balance, but if it succeeds, then we can simply transfer the token to the user, means admin wallet. So we'll take the token balance, we have to simply subtract the amount, and we'll say greater or equal to the deposited token, and then we can pass the token address, and we can simply say that can't withdraw deposited token. Simple logic. First we are checking the balance, then we are simply comparing the number of token user wants to withdraw, and then we are simply building all of these conditions. Simple logic. Got it? If everything is good, then we can simply transfer the token to the user. So we can take this user interface, we'll say save transfer, and then we can pass the message.sender and the amount which user wants to withdraw. And that's the entire function for withdrawing token from the staking contract. Simple. Look good? I hope you guys can understand. Now we can start working on the next function called modify pool. It's going to take the pool ID and the modified pool, means APY, UNT APY. It's going to be a public, only owner can call this particular function. And in that, first we have to get the pool. So we'll take this store pool, we'll have the pool info, and that we can pass the ID. So we'll have the pool. Once we have the pool, now we have to simply update the APY, and that's the simple thing. So that's how you can update the APY. Looks good. Now we can start working on a claim reward. So in that, we have to simply pass the pool ID. It's gonna be none reiterate. Then we have to find the pool. So we can say get this information like pool and the user. Simply copy this one, and that's what we can import. Let's format this. Once we have the information of the user and the pool, now we can come back here. We'll take this required, and we'll take this user dot log until and block dot timestamp. So we have to check the time, whether the time is completed or not. So we'll say lock is active, but if its lock is not active, then we can allow the user to claim the reward. So we can take this UNT variable, and we have to calculate the reward, and we already have this internal function, and that we have to simply pass the user information and the pool ID, and this will give us the pending reward. Once we have that, we can simply take the pending one. If it's greater than 0, then we allow to execute the function. Otherwise, we can say that no reward to claim. Now we have to simply transfer the reward. User last reward at, and we can say block.timestamp. Then we can simply call this pool reward token and call the transfer function message.sender and the pending the reward. After that, we can simply pass our notification. Now we can come back here, simply get this one, and that's what we can simply paste here. Looks good, format. So that's the entire function for claim reward. Simple. Got it? Try to understand the entire logic we are building. So let's call this claim. Got it? Now we have to build this particular function called create notification. So it's going to take few information. So it will take the UNT, means the pool ID, amount, and address, and the type of. So these are the information we are taking. It's going to be an internal function. So first we have all of this data. Once we have that, we can simply update in the notification. So we have to get the notification. We'll say push, and we can simply update the struct. So it's going to be an object type. In that, we have to simply pass all this information in the exact order. Okay. So first thing is going to be the ID. So we'll say pool ID. Second one is going to be the amount. Third one is going to be the address of the user. And the last one is going to be the type of. So we'll say type of. And the last one is going to be the timestamp, means when the particular function is got called. And looks good. That's the only thing we have to do here in this particular one. It's very simple. Now we have to call this particular function. So we are done with that. Now we have to work on the last function, and it's going to be a very simple one. I want you to pause the video and just give a try. Just give a try. It's going to be a one-line function. I hope you guys have tried. Now let me write the function. So what we're going to do is we're going to simply call this public view return, and it's going to return the entire notification. It's going to be a memory, and we can simply say return notification. In that way we can able to have the entire data of the notification, and that's the entire smart contract for our staking DApp. I hope you guys have understood. And here we have all of this structs. This is the user, this is the pool info, this is the notification, this is the decimals, mapping, this is the notification. Here we have the first function for add pool, looks good. This is the for deposit. So here we have the time log, we are going with 1 minute, but when we'll actually complete the entire project, then I will set for the 1 day. We're going to start this. Let's go. This one is the withdrawal one. Here we have the pending, reward. This one is the sweep, modify, claim, create notification, and get notification. Now we can simply start importing our library. So we are done with the entire smart contract for staking DApp, and I can see a couple of warnings. So it's going to be 4, sorry, my bad. So we can simply come back here. Before we update that, we can simply copy the entire contract of the library, and that's what we can simply paste. So simply remove this one and paste here. Looks good. So we have pasted the entire library. This one is a re-entrancy guard. Here we have the context, ownable, then we have address, ERC20, then we have ERC20 interface. We have all of this function, then we have the ERC20 metadata, and here we have the context and all. So safe math library we have, bring it, and here we have the actual contract we have coded. So I can see this warning is going to be for, because that's how you use library. You use for, not from. And if you are not good in Solidity, then make sure to check this particular course which I have. In that you will master complete Solidity development from beginner to advanced level, and we have built one of the biggest projects. So you will master complete blockchain development. These are the basic things which you have to know. So we got our library, perfect. Now we can check our contract one more time if there is an error. That's what we're going to fix it. So we can simply come back here. This is good, no problem we have here. And I can see a couple of warnings right up here. Okay, my bad, it's going to be storage. I hope you guys have noticed that. So let's change this to storage instead of string. Looks good. And now we can simply close this one. I can see one more problem. So I forgot to provide this semicolon. So let's provide that. And this will fix, because Solidity is a case sensitive. So if you don't provide this semicolon, it's going to throw an error. So it looks good. And I can see another warning. So simply copy and change this to storage. And looks good, there's no problem in that. And I can see one more problem here in the pending reward. So okay, my bad, we have to return something. So it's going to be a unt variable, because that's what we have to return. Looks good, unt, and this is fine. Here we have to change this to storage. Good. Now this is the storage we have. Let's cut that one. And here we have to change this to storage. This will be storage. Got it. This is good, no problem we have. And this is the create, looks fine. And this is the last function for get notification. Every single thing is working fine in our staking DApp. Now we're going to start working on our next contract. So let's come back here and let's have a look one more time. Looks absolutely fine. We're going to deploy and do the testing. So let's close all of the files, and now we're going to start working on our staking ICO. So click here, and this is the one we're going to work now for token staking. Now what I'm going to do is let's build the internal interface for ERC20 token. Then we're going to build the actual logic for interacting with the ICO contract. So let's build the interface. We'll say ERC20, and we have to build all the function which we have in the ERC20 token. So let's build the very first one. Is going to be a transfer. In that we have the address for the recipient, amount of the token. It's going to be external, and it's going to return a boolean, whether it's true or false. That's the transfer. The next one we have is for balance check. So it's going to take the address of the user, and it's going to return the balance. So it's going to be a unt variable. So let's call this unt. Then we have to build another one. It will be for allowance. In that we have to pass the address of the owner and address of the spender, and we'll say external view return, and it's going to return the unt variable. Now we can come back here. Let's build the fourth one. Is going to be a proof. In that we can pass the address of the spender, the quantity, external, return, and is going to return the boolean. Then we have our next function called transfer from. It's going to take the address of the spender, then it will take the address of the recipient, and it's going to take the quantity. It's going to be external, return, and it's going to return the boolean. Now we have the next one called symbol. So we have to find out this information internally within the contract. That's why I'm taking all of this interface. We can easily able to get all of this information from the front end, but I try to make it every single thing within the contract. So that's why we are building this. So let's call this external view return, and it's going to return the string memory. Means it's going to return the symbol of the token. We have to get the name, total supply, external view, and it's going to return the uint variable. And the last one is going to be the name, external view, and is going to return the string memory. So that's the entire interface we have for ERC20 token. Looks good. Now we can start working on our actual contract. So let's call this contract token ICO. Now we have to define a couple of state variable, like for the address of the token, honor. So let's start with the honor. We'll say address public honor. Then we have to take the address of the token. So we'll take this token, which we are allowing user to buy through this ICO. Then we can take the price of the token, which we are allowing to sell. We'll say token sell price. Then we'll have our total token sold. We have this 4 state variable. Now we can simply come back here. Let's take this modifier and we'll build a function for only honor. So we'll say only honor. In that we'll build the condition. So message.sender should be honor. Otherwise we have to simply throw this error message that only contract honor can perform this action, and we can simply continue with the function. So that's our modifier we have. Looks good. Now we can simply come back here. Let's build a constructor and we can simply update the honor address, and that's the only thing we have to do in the construction. Now we can start working on the function. So the very first function we're going to have is for update token address. So it's going to take the address of the token. It's gonna be, let's say, public, only honor can call it. Let's remove that, and we're going to simply update the address of the token. That's the first function. This is the, now we have to write the second function for updating the price. So we'll take this update token sell price. It's going to take the uint variable, means the price of the token. We'll say public, only honor can call it, and then we have to simply update the sell price. This is the 2 function is done. Now we have to come here and build a multiplier. It's going to be an internal function for calculating the price. So we'll say multiply is going to take 2 number. We'll call it x and y. It will be internal pure return is going to return a uint variable, which is going to be, so here we have to build the logic called condition. So we'll say y equal to 0 or z equal to x multiplied by y, and then we have to divide by y equal to x. And I can see this warning, okay, my bad, I have to provide this just because that's what we are returning from this function. So this is a simple multiplier function which is going to take a 2 number and going to multiply it. Now we can come back here and build a function for buying token. So we'll call it function buy token. It's going to take the token amount. It will be a public, payable. So first we have to check couple of conditions. So first is going to be the message.sender should provide the appropriate value. So we're going to use our library internal one, and we're going to pass the token amount which user wants to buy and the token price, the token sell price. So it's going to give us the actual data. If the price is not matching, means the user is not providing the actual amount which we want for making the transaction, then we have to simply throw the error message. We'll call this insufficient ether provided for the token purchase. Looks good. I can see this is the spelling mistake, I guess. Copy and paste here. And this is the first check we are doing. We are checking the appropriate value which user is providing. After that, we have to simply come here. We want to take this ERC20 interface and we have to get that particular token. So we'll take this token ERC20, and that we can pass the token address. Once we have the entire interface of the token, now we are ready to make the transaction. So this is done, copy and paste here. Now we have to simply check for another condition. So we'll take the token amount which user wants to buy, and we have to check whether the token is available or not. So we're going to take this token dot balance, and in that we're going to pass the contract address. So we'll take the address, this, simply remove this one. So in that way we can able to find out the token is available or not. If it's available, then we have to make the purchase, otherwise we have to throw the error message. So that's the check we are doing. Now we can come back here. Here we're going to simply build a condition called token transfer. If everything is good, we have to simply transfer the token. So we'll call this message.sender, and we have to transfer the token, the quantity which user wants to take it, and we have to simply multiply with the decimal points. So once we done with the transfer, we have to simply transfer the fund which user have provided to the owner address. So we'll say transfer message.value, and we'll have the fund. Once the transfer is completed, we can simply increment the sold quantity. And that's the entire function we have for buying token. So this is the first check. Then we are getting the interface and doing the second check, and then we are doing the transfer of the token and the fund and incrementing this token sold count. So that's the entire function we have for the buying. Now we can come back here, and here we have to build one more function for get token details, and it's going to be a function which we're going to use it. So we can simply come back here, we'll make it public view, and it's going to return a lot of data. So first it's going to return the, let's call say name, then it will return a symbol. After that we're going to simply return the balance. After that we're going to return the supply, and then we want to return the token price which we are selling it, and at the end we have to simply return the token address. So all of this data we're going to return from this particular function. So that's what we have, and I want you to give a try that how you can build this particular function. So I'm pausing a video for 1 second. I hope you guys have tried. Now let me write the function. So we can simply come here, we'll build the interface, we'll say token ERC20, in that we can pass the address of the token, we'll have the interface. Now we can simply do that very easily. So we're going to take this return, and we're going to call the entire interface function we have built on the top. So we can simply say token dot name, the function. In that way we can able to get the name of the token internally. Then we have to simply get the symbol. Once we have the, remove this one, once we have the symbol, then we can simply get the balance, address this, then we can get our token supply, then we can simply do return the token sell price and the token address, and that looks good. And that's the entire function we have for this. We can come back here, let's build another function called withdraw all token, and this particular function can only call by the owner of the contract. So it's going to be a public owner, and we have to build the interface for the token. So we'll say ERC20 token, we'll have the interface. Now once we have that, we have to simply do the check whether the token is available in the contract or not. So we'll say balance token dot balance, we can say address this, so we can know what token quantity is left. Once we can come here, and here we have to do a check. If it's 0, then we don't want to do the transfer. So we'll say balance should be greater than 0, then we have to continue the transaction, otherwise we have to throw the error message that no token to withdraw. After that we have to simply transfer the token. So we'll say this token dot transfer owner and the entire balance, and remove this one, and that's it. So this is the entire smart contract for our token ICO. This is the interface, this is the state variable, this is the modifier, constructor, update token, update price, multiply, buy token, and we have the get all, and we have the withdraw. I hope you guys can understand that how easily we are building all of this logic. So try to understand, try to rewatch and try to understand the logic we have implemented. So we are done with this entire smart contract. Now we can come back here, close this one, and now we are ready to deploy our contract. So before we do that, we can do a little bit cleanup. So we can come back to our context, and we have this ABI for ERC20 token. So I'm going to keep it as it is because we're not going to make any changes in the ERC20 ABI. So just keep it as it is, but we can do the changes in the staking DApp ABI. So simply come here and remove all of this because when we'll deploy our contract, we're going to get a new ABI, and that's ABI we're going to paste here. Let's do the same thing for this, and looks good. Now close this one, and we are done with this. So that's the only thing. I don't want to extend this video too long. It's already 40 minutes long video. So let's move to the next one.